Welcome to Head or Tail Education. Today our topic is Limits in Maths Part 3. In Part 3 we learned how to evaluate two limits, means the methods of evaluation of limits. Methods of evaluation of limits, we have three methods. So first, the method is by using the following theorems, evaluation of limits is solved easily. So number one is limit x tends to a function fx plus minus function gx. So equals to limit x tends to a function fx plus minus limit x tends to a function gx. Next, limit x tends to a, k is multiplied by function fx. So equals to k and limit x tends to a function fx, where k is constant. The third is limit x tends to a function fx is divided by function gx. So we have to separately take limit for both. So limit x tends to a function fx divided by limit x tends to a function gx. Limit x tends to a function fx is multiplied by function gx. So equal to limit x tends to a function fx dot limit x tends to a function gx. Fifth, limit x tends to a function inside another function gx. So equals to function, then limit inside x tends to a and gx. Sixth number, so limit x tends to a log fx. So equal to log, then inside limit x tends to a function fx. And seventh point, so if function fx is less than equal to function gx, then limit also x tends to a function fx is less than equal to limit x tends to a function gx. Or if function fx is greater than equal to function gx, then limit x tends to a function fx is greater than equal to limit x tends to a function gx. So these all theorems are used to solve the limits. Join channel for more tutorials. The second method is when to find limit of function on x tends to infinity. If you have the limit x tends to infinity, then in this condition is converted expression into 1 by x terms, then takes 1 by x tends to 0. So we will understand this statement by using example. So we have the example, limit x tends to infinity, 4x square plus 5x plus 6 divided by 3x square plus 4x plus 5. So solution is, first we take 2 common from up and down side, both side, means numerator and denominator. So here I take common x square, so 4 plus 5 by x plus 6 by x square divided by 3 plus 4 by x plus 5 by x square. So x square common from denominator and numerator. Okay, now cut the x square. So we have the only this expression of numerator and denominator. So if, because here I have converted x tends to infinity to 1 by x, so you have to take 1 by x equal to 0. So I put the value 1 upon x equal to 0. So after that we receive like this, 4 plus 0 plus 0 divided by 3 plus 0 plus 0. So equal to 4 by 3. This is the answer. One more example for this. So if here we have limit x tends to infinity, so 1 cube plus 2 cube plus 3 cube plus so on x cube and divide by x4. So for solution this, so you know already this is the sum of cube numbers, natural numbers. Okay, so we can write like limit x tends to infinity, x is multiplied by x plus 1 and divided by 2 and whole power of 2. So this is the general form of term summation of cube numbers, okay, and divided by x4. Next we use the power for this. So limit x tends to infinity, so multiply x square and x plus 1 whole square and divide by 4x4 power, okay. Next we expand this, so x square is x square plus 2x plus 1 and divide by 4x4, okay. Next we take common for this x square, so x square dot x square, and we have 1 plus 2 by x plus 1 plus x square divided by 4x4 power, okay. So first we cut the x square in bottom side, x of power 4, okay. Then this is also we know this is the whole power of 1 plus 1 upon x of square, okay. So we write like this. Next we use 1 upon x equal to 0, so we have the result of this limit is 1 divided by 4, okay. So this is the answer of this. So if you have this limit like x tends to infinity, you have to convert in terms 1 by x and then use 1 by x equals to 0. So this is the second method for this. Now comes to third method. So third method is saying if a belongs to R and limit of function fx on x tends to a, then following three methods we can use to find limit, okay. If we have this condition, so we can use three methods to find the limit. So first method is by using expansion of function, okay. So if limit of any expression on x tends to 0 to find and minimum one expression is expansible in given expression, then to write expansion of expression in increasing power of x, then we take common power of x and divide from numerator and denominator, then to be finished the indeterminate form of expression, okay. So first we take the example. So first we know what is the indeterminate form. So this is the indeterminate form, 0 divided by 0, infinitive divided by infinitive, 0 is multiplied by infinitive, infinitive is minus infinitive, 0 is power of 0 and 1 of power infinitive and infinitive power 0. So example, find the value of limit x tends to 0. So x minus 10x and divide by x cube. This is our question. Next, if we put the limit x tends to 0, so this is convert equal to 0 by 0 means indeterminate form, okay. So we, according to first statement, we required one expression for expansible. So here we have 10x is the expansible, okay. So we write like limit x tends to 0, x minus 10x divided by x cube equal to limit x tends to 0, x minus, so expansion of 10x, x plus x cube by 3 plus 2x of power 5 by 15 plus so on and divide by x cube, okay. Now cut the x and we have the next step, so minus x of power 3 by 3 minus 2x of power 5 by 15 minus so on and divide by x cube, okay. Next we take the common x cube from upper side, so here x cube I have common and we have the next step minus 1 upon 3 minus 2 of 2 into multiply x square divided by 15 so on. Now cut the x cube, then we have the form this and we use the x tends to 0 for this, so after using the limit we have the answer minus 1 by 3, okay. So this is the example of first point in third method, okay. Three methods. Next, the third of second methods, which name is by simplification of expression, means expression simplification. So first simplify the expression, then to be finished indeterminate form of expression. Okay, so for this we again take one more example for this. So we have the example, find the value of limit x tends to 2 x square minus 3x plus 2 divided by x square plus x minus 6. Okay, so solution, if we use the limit x tends to 2, so the expression is changes 0 divided by 0, means indeterminate form. Okay, so first we have to simplify this. So after simplification, so we find like x minus 1 is multiplied by x minus 2 and divided by x plus 3 is multiplied by x minus 2. Okay, now cut the x minus 2 and we have x minus 1 and divided by x plus 3. Okay, so limit x tends to 2 of x square minus 3x plus 2 divided by x square plus x minus 6 equals to limit x tends to 2 x minus 1 divided by x plus 3. So we use the limit and we have the result 1 by 5. This is our answer. One more example of third method. So this time is by simplification of expression. So one more example. So simplify and then output. So find the value of limit x tends to infinity. The root x is multiplied by root x plus 3 minus root x. Okay, so if we use the limit infinity, so this the form is converted into infinity minus infinity. This form is converted infinity minus infinity. Okay, so next to solve this we have to change. First we need to simplify for this. So to simplify, so limit x tends to infinity, root x is multiplied by root x plus 3 minus root x and is multiplied by root x plus 3 plus root x divided by root x plus 3 plus root x. Okay, so we convert like this. Now after this we find root 3 root x divided by root x plus 3 plus root x. Okay, limit x. Now common, here we take common root x from bottom side. So we have the expression 3 root x divided by root x and in bracket root x 1 plus 3 by x plus 1. Okay, so cut the root x and 3 by x we use the 0 for this. Okay, so here we have the answer 3 by 2 for this. So this is the third method to apply of this. So if you have a belongs to R and limit of function fx on x tends to a, the following three methods we can use to find. So this is the last method to find the limit by using the L'Hospital rule. Okay, so this rule apply only on the indeterminate form 0 divided by 0 or infinitive divided by infinitive. So first we understand what is the L'Hospital rule. So L'Hospital rule, so if two function fx and gx on point x tends to a, the value of both functions are 0 or infinitive, mean function fa after putting the value equal to 0 or function ga after putting the value equal to 0, both are equal, or maybe the function fa after putting the limit equal to infinity or ga equals to infinity. Okay, so means the both we have showing the indeterminate form like 0 divided by 0 or infinity by infinity. Then we can apply the L'Hospital rule according to this. Okay, so limit x tends to a, so function fx upon function gx equals to, if you have the 0 word upon 0, then we have to limit x tends to a f dash x and g dash x. Okay, so this is here f dash x and g dash x is the differential of function fx and differential of function gx separately. Okay, one is important point or condition you have to note for this. So this, after differentiating, this function is again not converted or changed into indeterminate form. If okay, so if again change in indeterminate form, so you have to again differentiate of function fx and gx separately another time. If you have again find the indeterminate form, then you have to again differentiate for separately. Okay, so note, separately differentiate for both function fx and gx while using L'Hospital rule. This is important. Okay, if you are using L'Hospital rule, you have to differentiate separately. Okay, functions, or you have to note also, if not apply, if you have the indeterminate form like 0 is multiplied by infinity, infinity minus infinity, 0 power 0, 1 power infinity, infinity power 0. So in this form you cannot apply the L'Hospital rule, L'Hospital rule. So if you want to apply to L'Hospital rule, you have to convert all this form into 0 divide 0 or infinitive divide infinitive. So this is the L'Hospital rule. Now example for L'Hospital rule. So find the value of limit x tends to pi by 2. So here we have sec x minus tan x. Okay, so this is the condition. The solution. So limit x tends to pi by 2 sec x minus tan x. If I put the limit, we found the form infinity minus infinity. So this is the indeterminate form. So first we have to convert 0 divide 0 or infinitive divide infinitive. So to apply this, convert like this. Okay, so limit x tends to pi by 2 sec x minus tan x equals to limit x tends to pi by 2 1 by cos x minus sin x upon cos x. Okay, so I write like this. And next, limit x tends to pi by 2 1 minus sin x upon cos x. Okay, now we differentiate for this. If we check limit pi by 2, okay, so put 1 minus pi by 2, so sin pi by 2 is 1 and cos pi by 2 equal to 0. So they can again convert 0 divide 0. Okay, so this is the indeterminate form of this time. So this time this indeterminate form is 0 upon 0. Now on x tends to pi by 2 is changed in indeterminate form. So now we can apply L'Hospital rule. So limit x tends to pi by 2, so d by dx 1 minus sin x, okay, and upon d by dx cos x. So after differentiate this, we found the limit x tends to pi by 2 minus cos x divide minus sin x. So after putting the limit, so minus cos x pi by 2 is 0 and minus sin x pi by 2 is 1. So we have the answer 0 for this. Now tell summary. In part 3, I tried to finish the lesson of limits. We learned the method of evaluation of limits. First one is by using theorems. Second one is to find the limit on x tends to infinity by taking 1 upon x tends to 0. And third one is inside we have 3 methods. So first method is by using expansion of functions, second method is by simplification of expression, and third method is by using L'Hospital rule. All methods of evaluation of limits we learned with example. Hope tutorial will help to understand method of limits, evaluation of limits in maths. Thanks to watch Head or Tail Education.